Hello everyone, my name is Kato Collins, and yes, today I'm continuing with the taxi fare prediction, and today I'm going to do exploratory data analysis on my data set. Yes, start right away. The contents, we are going to do exploratory data analysis, data set cleaning, Haversine distance, occasion the Haversine distance heat map for my data set, correlation matrix, outlier plots, illustration of trends in time, box plots, splitting data into 3 sets, fitting the model, and evaluation of the model. So to start right away, exploratory data analysis refers to the critical process of performing initial investigations on data so as to discover patterns, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary, statistics, and graphical representations. The importance here is it makes it simple to comprehend the structure of a data set, making data modeling easier. And the primary goal of exploratory data analysis is to make data cleaning. Thus, the data is free of redundancy. So we shall perform exploratory data analysis on our data set. So first of all, we shall do data set cleaning. So here we are checking for uniqueness of values in the data set. Yes, as we checked every feature, when we used our function of n-unique, it illustrated how many unique values are in every feature in our data frame. And when we checked for missing values, we didn't have any missing values in our data frame as well. And we also checked for duplicates. We had no duplicates in our data frame. And also in this dataset cleaning, we went forward to know the data types. Most of the data types we are dealing with integers. So that means they are numbers. And then the columns and rows which we are using. So they have assigned distance. To calculate this distance, it's the distance between the pickup and drop-off points. So as you know, we are dealing with taxi fare prediction. We must know the distance between pickup point and drop-off point. So the other sign formula determines the great circle distance between 2 points on a sphere given the longitudes and latitudes. So our sign distance can be found using GOP library, that is, or by implementing our sign formula by defining a custom-made function. All these methods can work, but specifically we picked one, which was GOP library, to calculate this distance. So this is the heat map for our data set. A heat map is a data visualization technique that shows magnitude of a phenomenon as scalar into dimensions. So this is a heat map that has all our features from the data frame that we loaded. So from this correlation heat map, it is clear that the distance, latitude, and longitude features have higher correlation with the target as compared to other features. And also correlation matrix. The correlation matrix is a table which shows the correlation coefficients for various variables. So below is a correlation matrix for our data set with variables such as fare amount, drop-off longitude, Haversine distance, and so many more as we've seen our features on the heat map. They also represented here, though the columns are not named, but this is our correlation matrix. So we also have outlier plots. An outlier is a value that lies in both extremes of data. So it is an observation that lies an abnormal distance from other values in a random sample from other variables. So the outliers we have two. This one of them shows passenger count plotted against drop off latitude, and that is a scatter chart. And also we have this other one which shows haversine distance against density. Haversine distance, which is the distance between drop off and pickup points. So we also have box plots. Box plot is a standardized way of demonstrating the locality spread and skewness groups of numerical data through their quartiles. There can be lines extending from the box indicating the variability outside the upper and lower quartiles. So box plots are used to show distributions of numerical data values, especially when you want to compare them between multiple groups. So one of the box plots we have shows passenger count. Most of the passengers that board are between 1 and 2. It is very rare to have cases of 3, 4, 5, and 6. Yes. And also the other one is number of passengers versus the days of the week. So as we can see, the days of the week down, and also the passenger count. Yeah, that is our other box plot. We also have illustrations of trends in time. So these trends in time show, one of them shows hourly variation of total number of pickups, the other one is weekly, the other one is daily, and the other is monthly. Yes, the fourth one in order as they are. So the observations we picked from here, even though contrary to the expectation, number of pickups is much lower during the morning peak hours. It is highest in late evenings. Yes, that's as expected. That's the time when most people are going off from work. Yes, and most of them need to go back home. So number of pickups on Sundays and Mondays are much lower than other days, with a peak on Saturday. Monthly plot shows significant variations towards the end of the month. Annual variation visible with first half of the year showing higher trips compared to lower. So we also split our data set into 3 sets. We had the train set, which was used to train our model, and we gave it 60% of our initial data set. We also had the test set, which we gave 20% of our initial data set, and this was used for testing the trained model. We also had the validation set, which was used for evaluation of our model to check whether it meets our requirements after it had been trained and tested. It was also given 20%. So we also trained and fitted our model. Training essentially means the process of increasing the knowledge and skills for a model for doing a particular task. So for our project, we used the train set. Yes, the one which we split it from the initial data set to train our model. And this is our train set, part of it. It was huge, so I got just a small piece of it, small screenshot. That is part of the train set. We also did evaluation of the model lastly, that is after all the training. So model evaluation refers to the process of confirming that the model achieves its intended purpose. We evaluated our model on the validation set, which was 20% of our initial data set. And these are the results we got after evaluating the model. So the model evaluation report, as you can see, the mean absolute error of linear regression was that 2 point. And also the mean squared error, our root mean squared error was also given. Also the explained variance score, the EVS of the linear regression. We used linear regression as the technique for training and as well evaluating our model. And Yes, it was 0.5, that is the EVS, and also the R2 of linear regression model was 0.5. Yes, thank you for watching this video. Subscribe, continue liking my videos. Till next time.